Hello. Following is a talking commentary for Chapter 7 in the Fundamentals of Managerial Finance course. Before we go ahead with the commentary, let's just start by describing the forest. In this class, we're talking about basic financial decisions. A good bit of that revolves around cost of capital and capital budgeting. If you read the chapter titles, you'll notice that about half the class is on these two topics, cost of capital and capital budgeting. It's important to most financial decisions that a financial manager might have to make. In this chapter, we're looking at the cost of capital for bonds, and additionally the valuation of bonds. The two ideas, cost and capital and valuation, are directly related through the mathematics and also the concepts. So as we go through this class, or this chapter, we look at bonds and we develop models for calculating their value. They're very similar to models you've seen already. And also we develop models for estimating or calculating the cost of capital. These models are also similar to other models used in this course repeatedly. A good bit of what we do in this chapter will look a lot like the time value of money chapter. So we're going to take the mathematics we learned in the time value of money, and now we're going to apply it specifically to the valuation on bonds. Bonds, what are we talking about? Well, for the most part in this class, we're in corporate finance, so we're talking mostly about corporate bonds. A lot of the content in this chapter could also be applied to treasuries, mortgage bonds, agency bonds, or municipal bonds. These are different applications of the same concepts. I think most of the examples you'll do are on corporate bonds. However, the concepts do generally apply. So as we think of cost of capital, we call this the bond chapter, right? We really are looking at debt in general. The bond structure is consistent, and it allows us to introduce the concepts of valuation and cost of capital in clear, simple methodologies. And so we have a tendency when we think about corporate debt to just limit it to corporate bonds. There's other debt. The concepts in this chapter could apply to other forms of debt, shorter or longer debt, but in this chapter we're focusing on bonds just to keep our analysis simple. So with that, the commentary starts with a basic review of key features or basic concepts. Let me see if I can scroll this down a bit. The par value. The par value is synonymously called the face value, and in many problems it's also the future value, which is a function on your calculator. The par value never changes. In most of the problems you'll do, the par value is $1,000. It's not necessarily a rule, but most bond contracts do state in the legal document that the par value is $1,000, and that's constant throughout the life of the bond. So in most of your problems, the par value will be $1,000, and it will last for the life of the bond. The second element or feature is the coupon payment or the coupon interest payment. It'll often be given to you as an interest rate, and again, it never changes. It's in the bond contract, and it's true for the life of the bond. If it's given as an interest rate, you'll take the interest rate and multiply it by the par value to get the coupon payment in dollar terms. Alternatively, sometimes it will be provided as a dollar payment. The maturity date. The maturity date is simply the years to maturity. Sometimes it's the initial years to maturity. For example, it's a 30-year bond, or possibly it's a 30-year bond with only 10 years left till maturity. We're concerned with the years remaining. When we price bonds, just like any other financial security, we're using or calculating the present value of future cash flows. So when we talk about a maturity date, we're concerned with all the years remaining, not the years that have passed. The yield to maturity. The yield to maturity is the yield if we buy the bond at today's price and hold it until maturity, at which time we receive the par value. We'll do many yield to maturity calculations. It is a very similar calculation to the cost of capital. In most applications, if we ask you to calculate the cost of capital, we're asking you to calculate the yield to maturity. We believe in efficient markets for the most part, and an efficient market says that the expected yield and the required yield based on risk should be the same. right? It's a pricing question. Efficient market says financial assets are priced accurately. If they are priced accurately, the yield to maturity should equal the required return on a bond, which should equal the expected return on the bond. They're priced accurately. There's no sales. When you go shopping, right, if you go into the store, many of us will actually look for deals. We'll look for products, dresses, clothes, tools, hammers that are at a discounted price. If the market is efficient, there are no discounted prices. That also applies to financial security. If the market is efficient, there are no discounted prices. We'll do many calculations on the yield to maturity. The market value is simply today's bond price. The call provision. The call provision allows the issuer, the corporation, to buy the bond back at a premium. You'll notice the next definition is a call premium. A call provision allows the issuer to buy the bond back at a premium. This usually takes place when interest rates have gone down. So if the interest rates go down and the issuing corporation feels as though they could reissue that bond at a lower interest rate, they may call it. You get a slight premium as the bondholder to compensate you for, the loss or the inconvenience, but this is an option for the issuing corporation. A call provision will also generate the calculation of the yield to call. So in some of your problems, in addition to calculating yield to maturity, you can calculate the yield to call. When you calculate a yield to call, there'll be two differences in most of those problems. One, the years to maturity will be shorter. Instead of looking at the years to maturity, you'll simply look at the years to call. And then secondly, the future value will not be the par value. The future value will be the par value plus the call premium. And that will allow you to calculate a yield to call. In most cases, a yield to call will be lower than a yield to maturity. Here we have the bond bullet concept. And this is a series of calculations on fairly straightforward bond values. You'll notice in the red box the first calculation computes the bond price to be $1,000. There's a video that goes through this. I simply want to point out some relationships through these next three bond calculations. The first is, you'll notice in this problem that the yield is equal to the coupon rate. The yield in this problem is 10%, and the coupon rate is 10%. When the yield is equal to the coupon rate, the price is equal to the par. Okay? So if you look at the 10% yield, it's equal to the 10% coupon rate, and therefore the $1,000 price is equal to the $1,000 par. That'll always be true. Okay? Once that changes a little bit from equality, then we have a different relationship. Let's look at the next bond. The next bond, is a 10-year bond from the same company, so it has the same risk, or maybe it's not from the same company, but it has the same risk, but instead it has a 13% coupon. How could it be that two bonds with the same risk, the same years to maturity, have such dramatically different coupons? Well, let's assume they're issued from the same company just to complicate the question. In one case, let's say the first bond we looked at with a 10% coupon, maybe it's issued today. Its initial maturity is 10 years. In this case, where we have a 13% annual coupon, let's suggest it was issued perhaps 10 years ago, right? At which time it was a 20-year bond, and the going interest rate on a bond of this risk was 13%. And now with only 10 years remaining, it's comparable in some sense to the bond we just looked at with a yield of 10%. All right, let's continue. So in this case, you can see the coupon rate of 13% is greater than the yield of 10. When that's the case, you'll notice that the price is greater than the par. Okay, so when the coupon is greater than the yield, the price is going to be greater than the par. This is always true. And then in the final example, you'll see exactly the opposite of that. In the final example, we're looking at a bond that has a 7% annual coupon. So in this case, the annual coupon is less than the yield to maturity. 7% is less than 10%. In this situation, the price is less than the par, and that again is always true. Further, let's comment on this price is less than par, and we refer to it as a discount. The price is below the par value. The par value is some kind of a standard assessment of the bond value. So when a bond has a price less than $1,000, less than that par value, we refer to it as a discount bond. Going back to the 13% bond, it was referred to as a premium bond. A premium bond has a price greater than the par value. In this case, it's $1,184. Let's continue on down to this diagram. This diagram is a useful illustration of these three bonds we just looked at, the 10% coupon bond, the 13% coupon bond, and the 7% coupon bond, all with similar risk and 10 years to maturity. What you'll notice is that 10% coupon bond, the coupon rate we're assuming is always equal to the yield, so the price on the bond is represented by the black line, which is always equal to the par. Going up to the 13% coupon rate, you'll notice that it sells at a premium of $1,184. The coupon rate is greater than the yield, so it sells at a premium. The premium is based upon these higher coupon rates. Which would you rather receive, $100 a year or $130 a year? Obviously $130, so you're willing to pay more money for it. As the bond matures, there's fewer and fewer coupon payments remaining, so the premium on the bond decreases until it finally hits $1,000 at maturity. Vice versa for the 7% coupon bond. It has a coupon payment of $70 a year. Which would you prefer, an annual coupon payment of $100 or an annual coupon payment of $70? Hence the discount. So this bond has a discount based upon the lower annual coupons. You can see that this discount decreases as maturity approaches and the price approaches the par value. From this point, we can see several more examples in the commentary, and pretty much all of these have, a video description of what's taking place in that problem with some very clear instructions on how to use your calculator. I'd encourage you to review at least some of these until you're very effective at using your calculators and getting the right answers. My experience with these calculators is that in the beginning it's hard to get used to them, but after you master them you will start to get the right answers with consistency. So if you are not at the point where you're consistently getting these right, I'd kind of double down on the time you're spending until you do. It's not necessarily a linear curve, it's more like a step. And once you start to get good at these, you will probably get them right with consistency, but until then, you'll struggle. With that, most of the rest of the content of this chapter is sufficiently clear, and if you have any questions, please provide an email or post your questions on the discussion sites. Thank you very much.